Hey everyone! If you've been following the Atlas saga here on the channel, today's update is big. Explosive, actually. 3I Atlas passed perihelion on October 29th, and instead of settling questions, it made everything stranger. We're talking non-gravitational acceleration, measurable trajectory deviations, and a blueward brightening behavior so extreme it's now logged as the object's 9th official anomaly. Even Harvard's Avi Loeb is impressed and urging the community to consider possibilities we usually avoid. Let's start with the hard data. On October 29th, at closest approach to our star, ALMA registered 3I Atlas 4-arcseconds off its predicted position. That might sound tiny, but in astrometry it's a klaxon. It means something besides gravity nudged the object. That's called non-gravitational acceleration. Regular comets can do it by venting, but when they do, you see the cost as mass loss. Meanwhile, 3 solar sentinels, Stereo, SOHO, and GOES 19, caught something no one expected. Atlas didn't just brighten. Its light skewed strongly toward blue, surpassing the sun's apparent color index from our vantage. That combination, anomalous acceleration and blue-dominant brightening, has never been recorded together on any comet, ever. Here, why that matters. If Atlas were just a natural comet being rocket-pushed by outgassing, the momentum change implies catastrophic mass loss. The estimate, at least 15% of total mass, over 5 billion tons, blown off into a massive debris cloud. If that happened, we should see it. We should be drowning in a halo of ejecta around the nucleus when the geometry is favorable. That brings us to the test that could change everything. Circled December 19, 2025. That's the close approach window when Earth-based and space telescopes get their best shot. If the debris cloud is there, the comet rocket explanation holds some ground. If it's not, if Atlas accelerated without the expected mass loss, then we're staring at a 10th anomaly. Thrust without depletion, an object changing course with physics that don't match the standard comet playbook. Now, layer in one more intriguing piece. Loeb pointed out that Atlas's passage offered a rare chance to watch gravitational lensing effects, our star subtly bending light from or around the object. His estimate, roughly 0.27 arcseconds of deflection, small but measurable with disciplined campaigns. If captured cleanly, that can refine size, mass distribution, and even test whether some of the brightening is geometric rather than purely thermal. In short, more clues to what we're actually looking at. If you're new here, or just want a crisp refresher, let's recap why 3I Atlas is already a once-in-a-generation mystery. Atlas is the third confirmed interstellar visitor after Oumuamua, 2017, and Borisov, 2019. But it's radically different. It's roughly 1 million times more massive than Oumuamua and about 1,000 times larger than Borisov. Yet it's also moving faster than both. Statistically, being the biggest and the quickest at once is vanishingly rare, well under 1/10 of 1%. Imagine the world's tallest person also shattering the 100-meter record. Nature usually doesn't stack extremes like that. From there, the anomaly ledger starts to fill. Anomaly 1. The impossible trajectory alignment probability around 0.2%. Atlas isn't just retrograde. It's nearly coplanar with the ecliptic, aligned within about 5 degrees of the solar system's orbital plane. Interstellar arrivals usually dive in at random angles. This one threaded the planetary table almost head-on. You can call it luck, or you can call it interesting. Anomaly 2, the sunward jet. In July-August 2025, Atlas developed a tight, forward-facing plume, material streaming toward the sun rather than away from it. Basic comet physics says sunlight heats volatiles they vent, and solar radiation pressure plus plasma wind broom that material anti-solar. Atlas did the opposite, a stable, collimated jet into the glare. That's unprecedented at this scale and distance. Anomaly 3, size and speed together, probability under 0.1%. We covered that, just note it compounds the oddity. Anomaly 4, perfect timing. Probability around 0.005%. Atlas lined up encounters within tens of millions of kilometers of Mars, Venus, and Jupiter, while slipping into total observational blackout from Earth near perihelion. Think 3 darts thrown blind, all landing on different targets, exactly when the lights go out for the referee. Isolated, it's a fun statistic. In a pattern, it's a raised eyebrow. Anomaly 5. Metallics. Spectroscopy shows a nickel-to-iron ratio far outside known comet norms, closer to engineered alloys than primordial rock. In natural environments, nickel and iron tend to travel together, born in the same stellar furnaces and condensed into the same early solids. Atlas departs from that script. Anomaly 6. Water scarcity. Typical comets are snowballs with dirt. Atlas is dirt with a little snow, only about 4% water by mass. That challenges our definitions and the thermal models we use to predict behavior near the Sun. Anomaly 7. Extreme negative polarization. The way scattered sunlight is polarized off Atlas's coma and dust doesn't match the catalog of natural cometary materials, even compared with Borisov. It's like light is being twisted by textures or compositions we don't see elsewhere. Anomaly 8. The inbound corridor overlaps within -9 degrees, the sky region associated with the 1977 WOW signal. On its own, that's not proof of anything. But in a growing anomaly stack, people take note. Anomaly 9. The perihelion blue. Recent, dramatic, and hard to reconcile with standard dust gas fluorescence and thermal emission at Atlas's solar distance. And now we wait on the potential 10th, acceleration without the expected debris. So where does this leave the debate? Avi Loeb's position is not it's aliens. His position is, when data don't fit entrenched models, test new hypotheses rigorously. That's how science grows. The pushback is familiar. Extraordinary claims need extraordinary evidence. Fair. Which is why December 19th and the coordinated follow-up campaign matters so much. Here's the decision tree, as cleanly as I can put it. If we detect a massive debris cloud consistent with greater or equal to 15% mass loss, the non-gravitational acceleration can be chalked up, at least in part, to directed outgassing. That doesn't solve the sunward jet, the polarization, or the metallic ratios, but it answers one branch. If we do not detect that debris at the predicted scale, we falsified the simplest comet rocket explanation for the measured acceleration. Then we're forced to consider other mechanisms, exotic volatiles, unusual geometry, electromagnetic coupling, or yes, non-natural scenarios. Either way, the result is scientifically valuable. If natural, we've found a new class of interstellar object with chemistry and radiative behavior we haven't modeled. If technological, then we're living through a first. Now, one more point that isn't getting enough attention. Precision astrometry and microlensing work hand in hand. The 0.27 arcsecond light deflection estimate is small, but if observers can isolate it from the glare and disentangle it from instrumental systematics, we'll refine mass and possibly infer internal structure indirectly. Pair that with polarization mapping and multiband spectra during the December window, and we'll either start collapsing the anomaly stack or confirm it with far better error bars. So what should you expect over the next few weeks? A lot of careful, boring, essential work, cross-calibrations between observatories, synchronized timing to catch any fast transients, deeper looks for structured spectral lines versus broad molecular bands, and a concerted search for that hypothesized debris cloud. If it's there, it will be found. If it isn't, that absence will be loud. No matter where the evidence lands, Atlas has already forced us to sharpen our instruments, our models, and our humility. Maybe it's a natural messenger from a chemistry we haven't met before. Maybe it's something engineered, still functioning after eons in the dark between stars. Or maybe it's a third thing we don't even have language for yet. Here, where I land tonight, skepticism and curiosity aren't enemies, they're teammates. Be skeptical of every convenient explanation, Be curious enough to test the inconvenient ones. December is close. The data are coming. What do you think? Strange comet, alien technology, or a brand new category of interstellar physics? Drop your theory in the comments. If you want the blow-by-blow as the observations roll in, subscribe. Because when Atlas hits closest approach, we'll break the results the same day. See you in the next one.